Okay, so this will be preparation for your lab for tomorrow. We looked through yesterday and the day before how to find the empirical formula of all the elements in a compound. Now we're going to look how to find the empirical formula of a hydrate, or in other words, how many water molecules are bonded to the ionic compound. And here's a hydrate. And here's a couple examples of it. It's a salt with a set number of water molecules bonded to it. So CaSO4 always has 2 water molecules attached to it. Cobalt chloride always has 6 water molecules attached to it. So our goal is, I'm going to give you an ionic compound. You're going to try and find out how many water molecules are attached to it. So there's 3 steps in order to do that. Step number 1. I don't know what's not showing up there. So step number 1 is convert the mass of the water and the mass of the salt to moles. So basically we're going to separate those. Think of them as being separate elements. Then step number 2, we're going to do just like we did previously, but we're going to divide each of these by the one with the least number of moles, and it's always going to end up being the salt, or the ionic compound, in other words. And then step 3, round each to the nearest whole number. Okay, there's not going to be multiplying or anything like that. Okay, so next slide. Here's our lab practice. This is going to be very similar to what you guys are going to be doing in the lab. All right, it says we have NaHCO3, so that is sodium carbonate. And what we want to find is how many water molecules are attached to it. So what we do is we heat it up, weigh it before and after, heat it up, and the water molecules are going to leave. And when we do that, we find out if we start with 1.8 grams, after we heated it, we now only have 0.9 grams. Okay, so basically we've driven off the water, and this is all we have left, the salt. So the salt weighs 0.9 grams. Well, how much does the water weigh? Essentially, how much did we lose? Well, we actually, for this problem, ended up losing 0.9 grams as well. It's not going to be the same number when you guys do it. So here's our steps, basically what we want to do. Okay, first of all, convert grams to moles. Okay, so 0.9 grams of sodium carbonate was what was left over of the salt. And this is the molar mass of sodium carbonate. So the mass of 1 sodium, 1 hydrogen, 1 carbon, and 3 oxygens is 84. So that gives us 0.01 moles. Then we conveniently also had 0.9 grams of water that were lost. Okay, so the molar mass of water is 18 grams per mole. So second step, divide each by the lowest number of moles. So we're going to divide each by 0.01 moles. And this, dividing those, gives us 1. And dividing these gives us 5 water molecules.